Good morning, good evening, wherever you are. We are back with another edition of How to Become an Architect. And in this specific video, we'll be talking about Docker and Kubernetes. We'll be touching upon containers and container orchestration. We have the usual culprits in here. We have Koushik, we have Siva, and I'm Ranga. Glad to have you guys in here.
Glad to be here.
Good to be back.
Let's start with the why question as usual. Why Docker? Koushik?
Sure. Docker is first of all, what is Docker? Docker is a container technology which allows you to have to run applications in a predictable manner. With a lot of applications, you need a bunch of things outside of the app to get it to work. So, for example, I gave this example of the runtimes, right? So if you're a Java developer, you need to have the right runtimes, the right version of Java installed, the right settings in place. There's a whole lot of things that are associated with running an application which is not code. We do a lot of stuff, a lot of testing, a lot of validation with code, but then these other surrounding things are kind of like they're left for at the last minute for production. So Docker is a way in which you can get all those things also into code. Like not only do you have code for your application, but also code for the environment in which your application runs. And that's forms what's referred to as a container. And Docker is one of the several container technologies, probably the most popular container technology to write code to manage your environment in which your application runs.
Perfect. So basically what you're talking about is you try and package not just the code of the application, but also some of its dependencies so that deployment and everything else becomes simple.
Yeah.
Shiva?
So the Docker is kind of one way of addressing it works on my machine problem. Like usually when you build the application, you have certain environment on your local machine. You use certain version of tools, and then you run it, and then you feel okay, it's running fine. But then when you shade the artifact, be it a jar file, be it a zip file, whatever, and they have to set it up, maybe a QA person or a production deployment person, they have to simulate the exact environment that you have. So there is a lot of chance that may go wrong. Whereas with the Docker, like you not only take your specific application artifact, you build the environment where you can take the entire package and run it directly. So that it drastically reduces the chance of having the mismatch of versions, tools, and all that. So that's a better way of distributing the application.
Okay, so basically once you have a Docker image, right? So define like once we create yeah, probably I'm trying to explain what a Docker image is. So when we have an application and when you'd want to deploy it to an environment, you can either take the application as is and configure everything step by step in the environment, or what we do if we are using Docker is we try to create a Docker image, right? We would create an image which contains maybe the OS, the application runtime that you would need, the jar, probably the configuration, the environment settings that you would want. All that is part of the package, so that now you are actually moving the package rather than a specific piece of document or instruction saying this is how it should be installed. And therefore, probably the chances of somebody making a mistake while deploying it is far lesser. Koushik, one aspect we can look at it, another aspect we can look at it is from the operations perspective, right? There are a lot of things which operations teams do, especially when we talk about things like microservices architecture, right? So there are a lot of complexities. Do you want to touch upon some of the benefits of containerizing in those kind of areas?
Sure. You kind of hinted at one of the things that is an operations benefit, which is what's referred to as a unit of deployment. Typically, with a Java application, a unit of deployment, or with any application, unit of deployment is what is that thing that gets deployed, right? What is the thing that you want to push to production? We want the unit of deployment to be as all-encompassing as possible. right? Anything that's not a unit of deployment is not in your control. You want something else to happen for your application to run. So all of the benefits of solving the it works in my machine problem can also be applied to it runs in this environment, or it runs on this server, it doesn't run on that server. It's basically the same challenges which affect deploying and having an application to run, right? Let's take a Java application. If your unit of deployment is a jar or a var, yes, you can put that in 3 different servers, but there's no guarantee that it's going to work exactly the same way on all those 3 different servers, because var is just a small portion of your application. There is another process which runs the code in your var, which is perhaps a servlet container, and the servlet container runs in perhaps a JVM. So there are multiple layers there. So rather than have that all be outside of what is being deployed, if the unit of deployment instead becomes a Docker image, for example, then the Docker process basically is what runs in your deployment environments, which basically takes this Docker image and creates a container out of it and then runs it. So this makes it very, very easy for operations folks to say, well, what is it that you need to do to make your deployments consistent and repeatable across different environments and across different servers? Well, it's a very small piece of it, which is having the Docker daemon which runs containers. Everything else is bundled into the unit of deployment. So that's a big advantage for operations as well.
Right. And also another aspect which I really love about Docker is the kind of standardization it brings in, right? So irrespective of whether you are building a Python application or a Java application, the technology which you use inside the application does not really matter. Once you have a Docker image, the operations team can treat it the same way. Siva, do you want to elaborate on that?
Yeah, that is one great advantage from the operations point of view. If you know, in the a couple of decades ago, it is like if you are a Java shop, your operations also kind of expected to have some kind of operational knowledge on the Java applications. What kind of memory settings we need to do, how to tune garbage collection. All this kind of a knowledge is expected. And if you are building a Python application, the kind of a setup is slightly different. Like it has its own way of deployment process and all that. But with the Docker now, it is all kind of a standardized. They don't care about what type of application it is. Of course, there is application specific settings that you need to provide, but by and large, it's all standardized. You need to tell them, okay, where is your image? What's the tag you want to deploy? And what is the resource requirements? How much memory you need? What kind of resource capabilities you need? That's all you need to say. And operations wise, it's greatly standardized, and it become very easy compared to the older way of doing things.
Absolutely. I think what we generally talk about is just the deployment aspect of it, but there are also other aspects related to operations, right? For example, the observability aspect of it. We would want to get metrics, logs, tracing, and this also is an area where having open standard, like if you look at Docker, like we have an open standard OCI, which almost all like container technology tools and frameworks adapt to. And by having an open standard there, like I see that the evolution of the further down the line, the observability, traceability, logs, and all that stuff also is really, really becoming pretty simple to manage. Koushik?
Yeah, no, I totally agree. It's there is a part of there is one part of it which is consistency of your images, right? So let's say you were referring to the microservice side of things. You're building you're building an application with maybe 20, 30 microservices. Not only do you need to make sure that each microservice runs in a consistent environment with a consistent set of services supporting it across multiple machines, you also need to make sure that that consistency applies across microservices. So if you have something like services which run on the production environment to gather memory data or some kind of telemetry, you can kind of bake it into a Docker image so that wherever that Docker image gets deployed, you essentially end up having that same template, right? You get that same cookie cutter and deployment environment, and that makes it consistent. Is that what you're referring to?
Absolutely, something like something on those lines, right? So
to give an example in the same concept, right? Like let's say in a typical Java application, or even in Python or Node.js, whatever application, there used to be different ways of logging. Finally, you want to log to some files or some way where you need to push all those logs to a centralized logging system. Earlier, it all depends on application you are using and the kind of approach you are following. Maybe you are writing to a file, and then there is some ELK stack where you read all those logs and then pump it to a centralized logging machine. Now with Docker, it kind of got simplified. You don't have to worry about what to file, what to write, and where to write, and all that. Just try to standard output stream, and then there is a standard mechanism of streaming all those logs and then pump it to ELK stack. So like this, there are many aspects that got standardized. Again, in terms of monitoring, earlier we used to have Jabix or some other monitoring tools to monitor how much memory it is consuming and all those things. Now, resource monitoring at the Docker container level is kind of again standardized. So there are multiple aspects of it that is getting streamlined so that it is becoming more and more standardized approach than technology specific or framework specific. It is getting standard.
Absolutely. I think the buzzword there is standardization. Whether we are building whichever language it is, and how you are deploying it, and how are you monitoring and looking at the observability things in production, you'd see that there is a lot of standardization which is coming in because of containers. Probably let's touch upon a little bit on let's go one step deeper. We kind of talked about creating a Docker image or a container image for an application. Koushik, any specific best practices that you would recommend? If, let's say, probably we'll talk about the Java space first, right? Any specific things that somebody who's getting into Java space with containers should be careful about when they try to build their first Docker image?
I would say, at least from my experience, I have fallen into the trap of premature optimization, over-optimization, and trying to reinvent the wheel instead of picking best practices from someone else. So those are things that I would recommend people watch out for. I'll give you an example. At a very simple level, creating a Java-based container is very, very easy, right? So you have container images which have Java baked into them. All you're doing is, if you have a jar, just put the jar into your image and have a run command which starts that thing. Not very optimal, right? Then you can go, okay, I'm going to break this down into multiple layers. Docker images have layers. So every time you add a command, it basically adds more and more stuff, right? So you end up adding more layers in order to optimize it, but it ends up becoming more problematic because you have way too many layers. These days, what I do is, for the most part, I will look for things where I don't have to do Docker images on my own. I'll probably look at something like the Jip plugin, it's a Maven plugin or Gradle plugin, to be like, okay, just apply what is the best practice and start from there. And then if that doesn't meet my need, then go start writing a Docker file. So this was a mistake that I made. So this is something that I would recommend people to watch out for. Like, don't start writing your own code just because you know how to do it. Start with what's available as best practice and then kind of work backwards. If it doesn't meet your need, then maybe look at what else needs to be done. That would be one advice that comes to mind right away.
Cool. So what you are referring to is, instead of writing a custom Docker file by yourself with the set of instructions, probably make use of something like a Jip plugin or some of the Maven plugins which are available to create your first container image.
Yeah.
Just to I think probably there is one aspect that you were implying in there. The layers, the Docker layers. Do you want to elaborate further on how Docker layers work and what are the things that you are trying to do when you are actually trying to layer applications? I mean, layer UI image.
Yeah. So the way it works, I'm going to give a little bit of an explanation in case the viewer is new to Docker. So when you write a Docker file, you're basically creating a bunch of commands, right? Writing commands one after another. And the way the Docker CLI creates an image from those commands is it basically creates all these intermediary images. Every command corresponds to an intermediate image. So each of those intermediate images is basically a layer in your final Docker image. The Docker image is, it uses its own file system, which is a layered file system. So your Docker image at the end is a combination of all those different layers, which may not be what you want. So, for example, let's say you copy 3 things from your project into your Docker image. So basically, that becomes 3 layers. The Docker is usually smart about handling layers. So, for example, if you're trying to do a new image build, and then let's say you have 5 lines in your Docker file which correspond to layer. Not every Docker instruction corresponds to a layer, but there are some where you're writing something which does correspond to a layer. So let's say of those 5 which results in new layers, the first 3 are not changed. The Docker caches it and intelligently uses the existing images. And then the next one, like, okay, this is what has changed. So it kind of creates a new layer out of it. So this is like the premature optimization that I used to do, which is when you're developing and creating Docker images, you're making changes to your code, and then you're building an image on top of it. So every time you make a change to the code, the layer at which you're bringing in the result of your code change is what is going to get changed, right? So the goal is to try and get that layer as close to the final layer as possible so that everything else gets cached. Because imagine that's the first layer in your Docker image. That cannot be cached. It kind of computes everything after that. So it becomes very slow. So adjusting the layers is one problem, like you have to be very careful about. So these are things that you have to keep in mind when you're writing your Docker file and managing how you optimize those layers.
Yeah. So not all things in your Docker image change at the same frequency. For example, if I have a Java application, probably the jars which I use will change very infrequently. The class files, the code that we write, will change more frequently. And therefore, our goal is to have that as top in the layer hierarchy as possible so that we can reuse the layers below whenever we build a Docker image.
Yeah.
Cool. Siva, like one another aspect which is very important when it comes to containers is optimizing on startup time and optimizing on the memory it makes use of. Do you want to elaborate why we would want to focus on that?
Yeah, sure. Like when typically these days we have a bunch of microservices, and if it is kind of a large organization and the kind of user base is huge, you may want to spin up containers more frequently. You may want to spin up more number of containers to serve the higher load. And you may want to tear down some of the containers if the load is not that high. So there is a kind of a vibrant environment where, depending on the load, you may have to spin up quickly to serve the incoming load. So the quicker the startup time, the better. Otherwise, it's kind of you are getting more and more requests, but you are not able to spin up the container so quickly. Let's say, I don't know how truth it is, but typically there is a conception of Java containers start slowly compared to, say, other languages like Go or something. They could be true. Because the nature of Java kind of first have to start the JVM and then your application initialization. Typically, if you are using reflection-based frameworks like Spring Boot, Quarkus, I don't think Quarkus is heavily depending on reflection, but generally what I'm saying is if it is heavily depending on reflection, it is kind of take more time than non-reflection based application. So we have to think about is there any way we can optimize this to make it more quicker? There are few approaches where, like again, if in Java world, if I have to really worry about my container startup time, maybe I look for Quarkus or Micronaut as well. Or even there is a new Spring Native initiative where, again, it's going to build GraalVM based image that really make it fast to start up the application. So these are few things that need to be taken care. And again, memory consumption. Again, depends on your application stack. If you're using traditional Spring Boot, not reactive or not Spring native, there is a chance that even in my experience, even for a basic simple CRUD operation application built by Spring Boot, you need 1 zip minimum. Otherwise, it's going to be very slow. So, but if you take any other Go based container, it's kind of a hardly the Docker image itself is hardly a few 100 MB or something like that. And then the container starts much faster. Memory footprint is also low. But again, this is the tricky part. Like, is startup time is really that important to you? Because what happens is when you are building your application and then you have a CI/CD setup where you have blue-green deployments, if it is some micros millisecond difference, it really doesn't matter. Like once it's fully up and running, then only the traffic is going to route to that new container. Otherwise, the old container still serve the purpose. So, but if you are running serverless kind of a workload, startup time is really, really critical. Then you need to carefully thought about what to do to make it more startup friendly. Otherwise,
Absolutely.
in a typical blue-green deployment setup, and if only milliseconds is the difference, that's kind of okay to live with, considering productivity of whole application deployment.
Absolutely, absolutely. I think one interesting observation there for me was like even AWS Lambda, for example, right? It started off as a serverless functions kind of service. Today, you can run containers using AWS Lambda. So you can just give it a container image and you can run it. And that's where, like, I think the startup times are becoming important. But as you said, if you're not in a serverless world, traditional blue-green deployment kind of a thing, then startup time might not be as important. But if you look at the memory footprint, right? So memory footprint, I think, will be really, really important, right? Because it dictates how much I can pack into a single VM. Earlier, it's like I have a virtual machine. The entire virtual machine is for the Spring Boot app. But now, like the less memory application consumes, the more containers you can pack into it. So that also plays a role in like the memory footprint. And if you look at the last few years, I think Java and Spring Boot, in a way, I mean, obviously newer frameworks, Quarkus, Micronaut, are really good at it because they are built for container and container orchestration world. However, Spring Boot was a little earlier, like a long back earlier. However, I feel the optimizations which are done in Spring Boot today, like I have a feeling you can build equally performant and equally less memory consumption kind of apps, even in Java using Spring Boot. Is that your experience too? Either of you, any of you have experience with that?
Personally, I see only millisecond difference or max 1 second difference.
Okay.
And I really don't know, like if it is a very dynamic environment where you have to spin up tens or even hundreds of containers, and especially if it is not serverless, that really matters. I mean, there is one talk by one of the person from Red Hat, a brilliant talk, why startup time matters. But again, in a traditional applications, in my experience, that really doesn't do much difference. Just to compare, let's say I have a framework where I am really, really productive, but it takes 2 seconds to start. And I have some other framework, I am not that familiar with the tech stack, and it starts, say, 500 milliseconds. Here, if startup time is really matters, maybe I'll definitely go with taking trouble of learning this framework and then building in this non so familiar tech stack. But if it is 1 second, 2 second is not really a big deal for me, then I would lean towards being more productive. That's what I would prefer.
Awesome. Koushik?
I agree with that. Time to market is more important than startup time for sure. I think having, one of the advantages that Spring Boot has is a lot of developers know it, they're familiar with it, and it's easier to hire companies find it easier to hire a Spring Boot dev than a Quarkus or a Micronaut dev. So yeah, my experience has been very similar. I have also spoken to someone who does Java application performance tuning, and he had an interesting observation. A lot of these new frameworks and technologies that come up, they kind of measure and demo with simple hello world type services. And they say, hey, look at this, it's a hello world service and it got in 2 microseconds or whatever else. The thing is, when you look at a typical enterprise application,
Absolutely.
you end up with so many classes, like hundreds of classes, and with a lot of these services being singletons, you essentially need to have, there is some time needed to kind of instantiate them and get them into the JVM. You can of course lazy load it, but most people don't do that. But if you were to take like a substantial number of classes that you need to instantiate, let's say 200 classes, right? Now, let's say starting one class with a Spring Boot application versus starting up one class with Quarkus, for example. I don't know why I picked Quarkus. No hate against Quarkus, just comparing, right? So here, like, okay, Quarkus saves 50 milliseconds. Great, big improvement because the actual workload is less. But now if you take a Spring Boot with 500 classes and Quarkus with 500 classes, the time it takes to instantiate and load those 500 classes is so high, we are probably looking at 1.5 seconds and 2 seconds. So those 10 milliseconds don't matter anymore because the large chunk of work is going to business logic and it is not framework dependent in any way. If you write that logic, doesn't matter whether you do it in Spring Boot or Quarkus or whatever else, those classes have to need that time to instantiate. So I think if you were to look at that, yes, startup time really doesn't matter. As Siva mentioned, time to market is much more important.
Cool. Okay, I guess that kinds of summarizes the entire discussion until now. Sure, go ahead.
Yeah, but one thing that really makes me curious and surprised is how much engineering effort goes into these frameworks. Like right now we have Spring Native and Quarkus and Micronaut. So in a way, they are all some way depends heavily on reflection, right? They dynamically, once you start the application, they inspect the annotations or whatnot, and then build a model of how to instantiate and create the components when you start the application. It's heavily reflection based, and we know how reflection works. But taking all that into the build time, like how Micronaut is doing and how Spring Boot is doing, Spring Native, I can't even imagine how it works. Like how at the build time they can figure it out, because you can put simple annotation that says conditionally load this bean if so and so condition met. How you can take that into the build time and then make it ready? I don't know how it works, but it is really fascinating. Maybe if time permits, I would like to understand how this magic works. It's really fascinating.
Sure, when you get the chance to explore that magic, do let me know. We'll have another session where we'll discuss that. Okay, well, like if I look at the entire my experience with developing software, right? I feel Spring was one really big event, especially dependency injection. The next big event I would think would be Angular, like the initial single page application framework, the concept of single page application. That was one big revolution. The next thing for me was Spring Boot, because it kind of simplified everything in the Spring ecosystem. And after that, I felt Docker and Kubernetes. These are the next big trends. Like if I have to list out 5 big trends in the last 20 years, for me, those are the big ones. I think we touched upon Docker until now. We'll move on to the next one, which is Kubernetes. And before we get into Kubernetes, Siva, do you want to start with why we need container orchestration? What is the use case for container orchestration?
Sure, yeah. So let's assume you build an application and then you create a Docker image out of it, and then now you want to run the application. Okay, you start a container and your application is running. Assume your application has some issue and then some memory issue or whatnot, and then it died. What do you do manually if you're running your application locally? Kind of you may need to look at it, why it's not working. Okay, container died because of so and so memory issues, and then you have to restart manually. During local development, maybe not a big deal, or even if you are using Docker Compose, you can say restart automatically, that works fine. But in a typical production environment, you want to make sure always my application is up and running. And more specifically, most of the production workloads that doesn't run as a single container, right? A single instance. You most likely want to run n number of instances to cater the high load. So how do you ensure that always n number of instances are running? That's where container orchestration comes into picture. So what, as a operations person, what we say, okay, this is my Docker image. I want you to make sure that always 5 instances keep up and running. And by any reason, if I want more instances, I'll tell you, and you figure it out. Okay, you are running already less number of containers, you spin up more. Or if I say, okay, I don't need those many containers, just make sure only 3 is sufficient. You figure out, you do the math, and then reduce the number of containers. And for any reason, if one of the container dies, you take care of spinning up another container and always make sure that n containers are running. So this is the setup we want in production. So this is what container orchestration tools like Docker Swarm, Kubernetes, all this tries to address. Uh, I know Docker Swarm is not as popular as Kubernetes, and I doubt anybody is using, at least recently in production, Docker Swarm. But I see Kubernetes is the most dominant Kubernetes Docker orchestration platform. So yeah, you want to run your containers at a production scale reliably, you need orchestration.
Absolutely. So taking a step back into your explanation about how you'd want to be able to reliably run a container for a specific microservice. Now, when we talk about microservices, there are a lot of microservices, right? So, and like you'd want to be able to do the same thing for n number of microservices as well. So a lot of microservices, and like another challenge is the infrastructure as well. So you'd want something which kinds of manages the infrastructure, the nodes or whatever wherever you want to run your applications on, and also take care of the logical part where you can configure, okay, these are the images and this is the configuration I would want for these microservices. Koushik, do you want to elaborate on, like just to take the step back, container orchestration? Do you see any other reasons why we should go for container orchestration?
No, Siva covered it really well. And here is where, we talked about the benefit of standardization with containers. Here is where we see the benefit manifested, because now, considering that all of these, for a typical application, you need various different kinds of containers. You need containers running like a Java microservice. Maybe there's some, some other infrastructure kind of service which is written in Python or whatever else. Since the container forms this uniform mode of interaction, like uniform deployment unit. Now we can have, you can write your Kubernetes code in such a way that you're treating all of these individual pods, as it's called, as kind of like the same thing, right? It kind of makes it uniform, and it allows you to orchestrate without not having to worry about whether it's like a Java microservice or a Python infrastructure service or a Node.js service or whatever else. So you get that same uniform API for managing containers, which is I think a significant benefit.
Absolutely. And also, if you look at the container orchestration frameworks, they also offer a lot of other features as well, right? You have multiple instances, so you can actually load balance between them automatically. You would want centralized configuration. So like if we look at the Spring Cloud world, right, most of the things that we think about as some of the features in Spring Cloud are somehow or the other provided by default by these container orchestration frameworks. So what the typical needs of whatever we call as like microservices architectures earlier, right? So when we talked about Netflix, Spring Cloud, and all that, like typically the things which we used to talk about are service discovery, load balancing, centralized configuration, distributed tracing. All those kind of features are kind of provided in like by default by the container orchestration frameworks. Siva, do you want to elaborate on any reasons why you think Docker Swarm was not as popular? I mean, do you have any experience with playing with Docker Swarm at all, or because if you see today, please go ahead.
I did very basic experimentation of okay, locally spin up a Docker Swarm cluster and then run a container and dynamically make spin up more number of containers, things like that. Very basic stuff.
Okay.
But I think Again, it's not related to very technical part of it, but typically Docker as a company, I think they haven't done a great job of marketing and capturing the market when there is a huge demand rising containerization. I think Kubernetes went ahead and hit the right time, right market, whereas I think Docker Swarm is not did a good job of marketing or reaching the people. Uh, but again, considering whole ecosystem, Kubernetes by and large does a whole lot of things compared to Docker Swarm. It's very minor compared to Kubernetes. I think enterprise needs a lot more than Docker Swarm. That is one of the reason I think. Even today, if your application is very small, you can go with Docker Swarm or HashiCorp's Nomad. They are good enough. But if you are running in a typical big enterprise environment, most likely you need features provided by Kubernetes.
Absolutely.
There was what people usually say is like Docker has had difficulty monetizing their offerings. They opened, like, they worked with the Open Container Initiative, OCIs, and they've done a lot of good work, and they have contributed to open source, but they've always had a challenge with, like, how do they make money out of this technology, even though the container technology is very popular. But I also think another thing which worked in Kubernetes' favor was that it was from Google. And when Google made that announcement, they opened it and said open source, they said, this is the infrastructure that has driven Google's own services. They're like, we use this, and this is known to work in Google scale. And now we are giving it away for free for open source. And I think that got a lot of interest from the community, because compared to Docker Swarm, which was kind of like, yeah, we are trying this out and we are trying for adoption, this one has been battle tested. And if it works for Google, it's very likely that it'll work for other companies as well, at least in terms of scale. So I think that was another reason.
Absolutely. I think if this is for the viewers, if you are interested in understanding the history of Kubernetes, there's a documentary called Kubernetes Documentary. If you just search on YouTube for Kubernetes Documentary, it's a 2-part documentary. Lovely documentary. I mean, I'm like, very rarely do we see documentaries on a technology. Like, we usually have documentaries on a lot of different topics, but on evolution of a specific technology and the entire journey they need to go through. A very important decision the developers who were working on Kubernetes had to convince their project manager was on open sourcing Kubernetes. So it's not a easy decision to open source something, and like the documentary clearly very well does a great job of explaining the choices, whether you have, what are the advantages of going for open source, why were they considering it to be something in-house, and that debate was also very, very interesting. And also the further evolution of the ecosystem, right, from Kubernetes is where the CNCF thing started as well. So the foundation where a lot of initiatives around container and container orchestration goes on today. Okay, cool. I think we touched upon a lot of things in there. Siva, if I would want to start with Kubernetes, what do you think would be the things I would need to focus on when I start off?
Okay. So typically when you think about learning Kubernetes, there are two aspects of it. Like, are you a developer who is trying to deploy your application on Kubernetes? Are you a administrator who wants to set up the cluster and manage the resources now? So assuming we are not talking about administration side of things. From a developer point of view, first we need to understand the Kubernetes primitives, like what is pod, what is replica set, what is service, what is the deployment, and what each kind of object is responsible for. Why not just use pods? You can spin up pod and then you can access it, but why you want to go with the deployment? What is the role of a replica set? So understanding these primitives is very critical to use Kubernetes effectively. And then a little bit more is kind of ingress rules and how you route from a domain URL to your pods. How do you route the traffic? So, and also when we go to container world, right? Most of the times we build our application and parameterize all the configurable properties. Like you may want to run the same container in a different environments, be it in a QA environment, staging, prod, different environments, and you may have to parameterize all those inputs. So how do you feed that environment variables? Most of the times you go for environment variables, and then what kind of a provision Kubernetes provides? Like there is a config map, there is a secrets. So these are the ways that we can feed these environment variables into the containers. So understanding these are kind of a critical. And I would recommend if you are newbie to the Kubernetes world, there are tools that you can spin up locally like Minikube or Kind. It is kind of easy if you have good enough RAM, and you can spin up a cluster and then you can play around and then see. One challenge is kind of writing the manifest files. Like when I first started, I got lost in so and so Kubernetes YAML files, a lot of labels and names, and labels are at different levels. I kind of got lost. But if you thoroughly try to read and understand, they're kind of nested one in another. Like if you are starting, first you may try to create a manifest file for a pod, and then you see a lot of same kind of tags. And then when you try to write for a deployment, you see almost same thing, but nested inside another object. So initially it kind of a bit of overwhelming, but you kind of try to identify the patterns. It's not that complex, and especially coupled with IDEs with so much of auto completion capabilities, it's fine. You can get habituated to that. And there are tools which actually generate these manifests. You don't have to manually write them also. But I am kind of a skeptic about how good their generated manifests are. But again, you can start generating and then tweak them. You don't have to use them as it is. You can tweak them. This is what I would suggest. Run Minikube or Kind, and then I would strongly recommend don't go for generation of a manifest beginning. Learn how to write them properly, and then deploy and then see. Just if in case anybody is interested, recently again I got so much fascinated by Kubernetes, and then I wrote almost 5-6 blog posts. If you are a typical Java Spring Boot guy person, you can just follow along how to use pods, how to use services, how to use deployments, ingress rules. I wrote a series of blog posts. That's a good starting point. Yeah, I think beyond that, there are a lot of administration type of activities like nodes.
Sure, let's get to the
clusters, and
administration part a little later. Let's first focus on the developer part.
I am not even familiar with the administration part.
Yeah, I think getting to an administration part would be a complex thing. Like I know how challenging it is to set up to get a simple Kubernetes cluster running in my local machine 3-4 years back was a challenge, was a really big challenge. It was like you needed to configure so many things, and you needed really powerful machine as well. And yeah, and that's why what I did was actually I started learning Kubernetes in the cloud. So like Kubernetes, like each of the cloud platforms offer Kubernetes service, but the Kubernetes services from AWS and Azure are not free. So they're not part of the free tier. That's why I chose to go with Google Kubernetes Engine, which was like if you go for a Google free account, it's easy to create and kind of use it. But again, the free tier accounts come with their own limitations as well. So it's you can use the free tier only once. So, but like it was a huge challenge to set up a cluster. That was the first challenge I faced when I started with my Kubernetes journey. And you touched upon some of the very, very important concepts in there, right? I think understanding pods, replica set, deployment service, and what is the role each of them play in Kubernetes, and the importance of labels, because labels are the things which you write in your deployment manifest. Like attaching the right labels with your Kubernetes objects, like pod, replica set, deployment, and service, and using the right labels in your deployment configuration or the YAML file. A lot of, as you say, like it was a struggle for me as well when I started my journey with understanding the deployment configuration with the YAML especially. But it's like magic, right? Once you understand it, it's like a lot of times there are things which are really, really complex, but once you understand them, it becomes a magic. Like you can do so many things using that one example is like the release strategies, right? By making the deployment configuration, the YAML, so complex, you can kind of do variety of release strategies just by playing with the YAML and things like that. That kind of flexibility is what I think, what I love from Kubernetes. Koushik, do you want to touch upon any other thing?
Sorry.
Please go ahead, Siva.
So I just want to say this labels thing is very interesting. Typically when we see anything attach a label, that's kind of not so important. It's nice to have, maybe let's say it's a dev environment or what. That's how we feel. But in the Kubernetes world, labels play a very, very crucial role. As you said, we get to know how many things we can do. Like you can just tag and then I think blue-green deployments and all, many things heavily rely upon these labels. So
exactly.
yeah, if you are learning Kubernetes, get a good hang on what labels are, how to use them.
Absolutely.
I actually had a question for you, Ranga. So you talked about the cloud services for Kubernetes with AWS, Azure, and Google Cloud. Is it true that the Google Kubernetes engine is a little closer to the core Kubernetes implementation as opposed to AWS and Azure? Like, are they wrappers, or can you still use the same Kubernetes configuration for all the three? Like, you make it cloud agnostic?
Yeah, it's 99%. I would say it's the same. It's like the same Kubernetes. Once you are adhering to everything related to Kubernetes, the deployment configurations, how you create the cluster, everything would be the same everywhere. There would be obviously like a little bit of changes that are customized to that specific cloud. But if you just look at the container orchestration part of it, all three services are essentially the same. The only difference comes in is the amount of experience Google has with Kubernetes. Right, AWS was a little late to the game. They did not want to take Kubernetes at all initially, right? So, I mean, obviously, it's a technology coming from Google Cloud, and I'm a competitor, so I'm a little reluctant at the start until it really became popular. Azure and like AWS were little reluctant. So, the amount of experience Google Cloud has in managing reliable clusters, Kubernetes clusters, shows in GKE, right? I never had a problem with the GKE cluster at all in like my 4 or 5 years of experience playing with it. So yeah, it's like, I think it's just in the stability that there is a difference between these three. It's not, and now I would say even stability is not such a big thing, because like each of the cloud platforms have Kubernetes services for at least 2 to 3 years now. So initially it was a challenge, but now I would say almost all three are stable. And if you want to run Kubernetes, you can go anywhere. And going further, like there are multi-cloud abstractions on top of these as well. So there are abstractions which you can make use of, and you can have clusters which are in like each of the three clouds, and you can manage them from a central location. Google Cloud offers a service for it. Azure offers a service for it. AWS offers a service for it. If you don't want to go for any of those, you have OpenShift as well. So yeah, the underlying infrastructure is almost becoming kind of so standardized that now people are focusing on the layer above.
Yeah. So if this works, what is a good use case for somebody to go like a beanstalk, or like somebody taking Elastic Beanstalk, or maybe doing some kind of an elaborate CloudFormation template, set up all these different services, as opposed to doing all things Kubernetes? Like, what is the factor that would influence some business or some enterprise to go one versus another, in your opinion?
Right. It's actually, if I have a simple application to deploy, I don't want the complexity of Kubernetes, right? Kubernetes comes with a lot of need, I mean, in terms of understanding the clusters, running clusters efficiently, because you are deploying containers, you would want to make sure that every node is completely utilized. So there are a lot of factors which are involved in running a cluster efficiently, and also in terms of the developer knowledge which is needed. It's like the step up is too high. Like once you do the step up, it's easy, but the step up is not easy. So those are the two factors I see in like in staying away from Kubernetes when you have simpler problems. And if you just have a simple web application to run, and if it's independent of everything else, why do I need to make it part of a huge ecosystem? I can actually rather have something simple to run it.
Yeah, I think Beanstalk is a AWS attempt of providing fast kind of approach. You don't care about how things work under the hood. You just tell me where is your container and what you need, and I'll take care of the infra part. But that is, as Ranga said, that is sufficient for simpler applications. But if you are building a lot of applications and the complexity is more, maybe it justifies the complexity of adopting Kubernetes. But for simple applications, Beanstalk or any PaaS platform is sufficient.
Yeah, Beanstalk is just one of the possibilities, right? So a lot of these cloud providers have, auto scaling technology, and you don't have to use Kubernetes for it. So that's a fair point. If all you're looking for is a very static kind of an auto scaling strategy, which is simple, that there's a cutoff at some point, you're going to go, well, this is not going to work, and switch to Kubernetes. But until you hit that point, it's better to go with a native auto scaling technology provided by a cloud provider. And then once it becomes too big, that's when organizations say, well, now we have to go the Kubernetes route. That makes sense.
Yeah. And also, like, if you're in the container world and if you'd want to be able to run containers efficiently, like, there's a wrapper on top of Kubernetes, which is Knative, which also allows you to run containers in a serverless way on Kubernetes kind of infrastructure. So that's also another thing which people can explore as a intermediate step. If you don't want to go to Kubernetes directly, probably you can make use of some of the Knative implementations. Like in Google Cloud, there is something called Cloud Run. AWS also offers like its own container orchestration solution, ECS, and there's a serverless version of it also called Fargate. So those are options. Like Azure also offers something called Azure Container Instances. So they have options as an intermediate thing before they would take the full jump in. Cool. Okay, let me get back to the list of things I had. Yeah, probably let's, I think we discussed some of the important concepts around Kubernetes. Let's probably talk a little bit about the ecosystem around Kubernetes. One of the challenges, Siva, you were talking about was understanding the deployment configuration is like not easy. And that's where there are a number of solutions, right? Helm is an example. Do you want to elaborate on that?
Yeah. So let's take an example of you built a Spring Boot application and you created a Docker image out of it. Now you want to run. In a bare minimum approach for running on Kubernetes, what you need to do, you have to create a bunch of manifest file defining your deployment and your service definition and how many instances you want to run, how many pods. So you have to prepare all this. Just imagine what you can do. Suppose you are building a second Spring Boot application, which is more or less very similar but different functionality. You have to either copy paste the whole thing and then change the Docker container image name and things like that. So the idea is to abstract away where you create one higher level abstraction and make it parameterized so that you can pass, okay, what's your Docker image and how many pods you want to run? What is the config map? What is the configuration environment parameters you want to apply? So it's a kind of you can create a higher level abstraction. So Helm is a tool to do that. In Helm world, you call it as a chart. That is nothing but a bunch of manifest file which accepts some overridden parameters. You can provide what container you want and what is the resources you want. So that's a kind of if you have, yeah, typically in organizations that standardize on some technologies, that's a really good way to boost the productivity. Like you have a bunch of Spring Boot applications or Python applications. You can create these Helm charts and then every team doesn't have to copy paste the same bunch of manifest file. You just take the Helm chart and provide the overridden parameters. You can you're like Helm. There are, I think, customized and yeah, these are the two I am familiar with, which does the same thing. Provide a one level higher abstraction on top of Kubernetes manifest file.
Absolutely, absolutely. And also another place where Helm really helps is like if I want to run, for example, a Kafka cluster in a reliable way, right? So earlier it was like I have a Kafka image, but to run it, I would need to create my own declarative configuration file. And Helm kinds of provides configuration, like the charts around that, so that it's easy to like reliably run different kinds of software on your Kubernetes cluster as well.
Yeah, because there is a Helm chart repository. I think a lot of people build high quality charts and then publish it. For example, if you want to run a Postgres, usually in Kubernetes world, so far what we have been discussing is stateless services, right? But running stateful loads like databases and all is whole new level of complexity. But good skilled people out there, they build the charts and then they publish it. Let's say Postgres. If you want to run Postgres as a container, you can leverage those Helm charts so that you don't have to worry about all that configurations. So it very much improve productivity. Like you don't have to worry about creating.
Absolutely. Another important part of the Kubernetes ecosystem and one recent evolution of the last year, maybe couple of years, is this talk about GitOps, right? So instead of actually, like usually when we talk about DevOps, it is prescriptive about doing infrastructure as code. It's prescriptive about doing continuous integration, continuous deployment, but it does not really tell you how you should do production deployments. And like GitOps kind of focuses on that specific aspect as well. Just like I know that I can build a jar from my code. I don't directly create a jar. I would first commit it to my GitHub repository, and I would probably build my image from the code which is present in the GitHub repository. Just like that, I would say like GitOps is kind of trying to standardize around how you do the production deployment, like infrastructure as code templates, the Kubernetes configuration. Everything should be in the GitHub repository, and also it's prescriptive about how you take them live. Like it should not be a manual apply. It should be something automated which actually takes all the Kubernetes configuration and puts it live. Siva or Koushik, any experiences with that?
I haven't used in production or anywhere, but just I played around with a bit of tool called Argo CD. So the idea is, let's say in a typical CI/CD pipeline, let's say you are using Jenkins. Okay, you submit your PR and then it is built, tests are run, and Docker image is created. And now you want to deploy it on a Kubernetes cluster. So for that, you need to give the credentials to authenticate to Jenkins to deploy this Docker image onto this Kubernetes cluster. Let's say you have such integrations in for many clusters. So all that credentials you need to provide to the Jenkins server. It kinds of a push model where you have the image and you need to push to those clusters. The challenge is there is no way to know. You can just trigger the pipeline and then apply the Kubernetes manifest file, but you won't get to know the feedback of it, like whether they successfully ran or they failed. It's hard to get the feedback from it, and also it kind of increases security problem. Like now you have all those credentials centralized on Jenkins, whereas this GitOps is kind of a pull model where just like our code, you put all your infrastructure part of it into a Git repository, and whenever there is a change, you just apply these changes into the containers. But the thing is, you run this GitOps tool, what our CI/CD tool in case of Argo CD, you run it already on the Kubernetes cluster. So it pulls all those manifests from Git repository and then apply onto itself. So there is no need for configuring these credentials in a centralized place. It's all kind of a full model. I just played with the Argo CD. It looks fantastic. Like you just commit your code and then your pipeline build the image and push it somewhere. And then GitOps tool that pulls the image and then apply. Is there any newer version? Just apply it. But I see there are kind of a challenges in that model as well. But I'm not really into DevOps world to first-hand experience those issues. But as a user, it looks really good. Argo CD, just we can try it if you have a local cluster. It looks really good.
Absolutely, absolutely. And also like the fact that you have complete version of what happened in your production, complete history. It's not a manual execution of commands. It's like, just like you have the version control, version history for code, what changes happened, why. You have some kind of that for production as well. I mean, at least theoretically speaking, it like I love the concept. I have not seen it in action anywhere, but when I heard about GitOps, like it's something which I really like. I'm sure there would be definitely a lot of challenges in using that.
But don't you get that with DevOps anyway? The versioning, that record keeping is available in DevOps. The minute you put all that infrastructure code in your Git repository, you already have that. GitOps is kind of taking that one step further And I don't think, like, I haven't played with Argo CD. I should check that out. I don't see, at least in my experience, the organizations I've seen are kind of hesitant to do GitOps. They're a little scared. So they want that, like, even for pushing code, they need that manual intervention to make sure everything is going fine. Most enterprises hesitate to just have code go from commit to deploy all the way. So if they're freaked out about that, imagine the reaction when they say, okay, even infrastructure is going to go all the way. So I think that is a little bit of a concern that I've seen other people do. I haven't had experience with GitOps myself as a result.
I think it is more of a fear. Let's take an example of we have a repository where we are committing, be it a Terraform or any approach. So the idea is as soon as you commit it, and then if there is a pipeline that is going to take that and then apply it on the infrastructure, maybe it deletes a whole bunch of things which we don't want. So
Yeah.
the idea is like you might have some kind of a review system in place. So only you apply this if you are committing to a specific branch, and not everyone has the authority to commit to that branch.
Right.
So because the problem persists in either way, be it GitOps or you have in some repository and then it automatically applies. So you have the risk anyway. But again, if by mistake we commit some bad code, nothing really horribly happen. But infrastructure, we need to be very, very cautious. Like just one mistake, your entire infra is gone. That's not what definitely anybody wants.
Absolutely, absolutely. Any finishing thoughts about Docker and Kubernetes, Shiva and Koushik? Let's start with Shiva.
Yeah, to my understanding, like already what I have seen in the community is Kubernetes and Docker adoption is already it's a given. Like most likely you will be using some Docker, be it at least in local development environments or in running applications. So, and considering the amount of flexibility and standardization Kubernetes brings, more and more organizations are going to adopt. So, I would strongly recommend learning Kubernetes. And maybe you are not a Kubernetes admin, but having good decent knowledge on Kubernetes as a developer, that really plays for building cloud native applications. You got to understand how things work on the other side, even though you are not the one who is maintaining it. But definitely, I would strongly recommend learning Kubernetes.
Awesome. Koushik?
I learned a lot today talking to you folks, so thank you for that. Yeah, I'm very excited about Docker and Kubernetes too. I think Kubernetes, well, even containerization came at a good time when microservices were becoming popular, and I think those two kind of go so well together. They're actually empowering each other, right? Microservices is getting momentum to Docker and Kubernetes, and the same way, the growth in Docker and Kubernetes is actually making microservices much easier. So yeah, I'm like I said, it's market has already adopted it, so it's a great time to learn Docker and Kubernetes for sure.
Absolutely. And like another sign that Docker and Kubernetes, I mean, especially Docker is here to stay, or containers are here to stay, is that earlier we were only using containers to run maybe web applications, REST APIs, things like that. But today you would see that containers are used even in ML, even in data engineering, even in things like ML on the edge, right? So they are trying to create so small container images so that you can actually run it directly on the device. So yeah, the use cases of containers are exploding, and like it's almost a given that in a few years, almost everything would be using containers. The Kubernetes ecosystem, I mean, Kubernetes for me is a big step up. That's why probably I'm doubtful where it's heading. But I mean, if you look at the cloud adoption and the flexibility you have today to run Kubernetes clusters, maybe Kubernetes is here to stay. But yeah, either way, I think Docker and Kubernetes are great options to consider if you are learning, if you're planning to learn something new. Thanks a lot, Koushik. Thanks a lot, Shiva, for your time. I'll see you again very, very soon. Thank you.
Thank you.
Thank you, Ranga.
I'm sure you had a great time watching this video. If you loved this video, do not forget to like, share, subscribe, and comment as well. Our goal at In 28 Minutes is to help you learn cloud, DevOps, and also programming. So go ahead, keep learning every day, and I'll see you again.